Our session on data stewardship. My name is Associate Professor Libby Liggins. I'm from the University of Auckland and I'm part of the Scientific Committee for the World Data System. So, yes. Sorry, thank you. Kia ora and welcome to our data stewardship session. My name is Libby Liggins. I'm from the University of Auckland and I'm part of the Scientific Committee for the World Data System. I'll be chairing the session today. I want to begin with acknowledging the traditional owners, the Turrbal and Yugera people of the land that we're on today, Meanjin, and pay respect to their elders past and present. Today we've got an online speaker, we've got a recorded presentation, and we've also got in-person speakers. We have people joining online, so I'll ask that if you have anything, when there's an opportunity to ask questions, please speak into the microphone so that they can hear, like I haven't when I started. Each speaker will have 9 minutes, and my associate here will be helping to keep time. Save all your questions for the end. If you think you're going to forget them, feel free to use the Q&A app to enter your questions there. But at the end, if you're in the room, you'll have the opportunity to use the microphone and ask the presenters yourself. Great, so I'll invite our first speaker up, unless... do we have an online presenter? No. Okay, so we don't have Nicolas right now. We'll get him to join if he can later on, but we're going to start with Anu.
Hi everyone, my name is Anusuriya Devaraju or Geoscience. I'm a data architect from CSIRO under the Mineral Resources Discovery Program. So basically I oversee the data management of my program. So today I'm going to share with you some of the practices and digital solutions we developed to streamline physical sample collection management access within our program. First, I would like to begin with acknowledging the traditional owner of the land on which we present today, and let's together pay respect to elders past and present. So for those who don't know what are the samples, physical sample in geosciences, so these are examples of samples. They range from cores, and then from the cores you can extract microanalysis samples, for example, thin section and polished blocks. And then we have a soil samples, vegetation sample, and groundwater sample as well. As you can see, all the samples we collect in our program are diverse. Samples are important research asset in our program because they actually provide direct, tangible evidence that support research findings. And they also usable resource for future research. For example, the geologists, they collect samples to identify mineral composition of rock, which is essential for understanding potential mineral deposits. So the challenges, before we develop these solutions, there are two challenges which you can categorize into digital access and physical curation. So within the programs, there was no central sample catalog to locate samples. So basically, the researcher finding is a bit difficult to actually locate samples beyond their project unless they get in contact with the project lead or laboratory technician who prepare the samples. The second challenge is related to physical curation. So in our program, the sample handling is managed on a project basis in an ad hoc manner, which means that this poses several issues. There's no standardized way on how we should handle the sample, starting from the collection up to archiving them in a proper storage facility at the end of the projects. So this causes several issues. For example, as you can see in the picture on the right, the sample box container in a pallet, they collapse over time. Often we found unlabeled or unknown sample at the different part in the buildings. So basically, the discovery program, which is I'm part of, they actually funded a strategy project. It's a one-year project to streamline physical sample collection and access. We have successfully delivered the project last year, so currently we have started with the second phase of the project, which started this year, August. So what I'm going to share with you today is the three main components. Before that, I also want to share about my project, information about the project team. One of the main reasons why we have successfully delivered the project is that our team is very diverse. It consists of the laboratory technicians, managers, scientists, as well as digital engineers. So I'm going to talk about the main output from the project, which I categorize into these three main components. These three main components are important to ensure effective sample curation and management, and they have to work together. So I'm going to go through each of these components in the coming slides. So I will start with the processes. So it's basically anything to do with guidelines and procedures, like how we should curate the sample, how should make access to the sample. So what we have developed is practical guidelines. So these guidelines contain recommendations and also procedures in terms of what are the role, what is the responsibility, how you should label the sample, how you should package them, how you should store them, and also how you should record the information. In addition to that, we also have developed several standard metadata templates and control vocabulary as well. So one important aspect from this guideline is the end-to-end workflow. Basically, for each of us, basically we look at the sample life cycle, starting from project planning up to collecting sample in the field, and then bring them into the lab, prepare the samples, and they get analyzed in the analytical instrument, and finally how we curate them in a proper storage facility. For each of these phases, we actually identify what are the role and what are the action needed. And this end-to-end workflow is developed based on the iterative feedback from the technician, basically the people who are actually part of the operation. So it's not like something top-down. It was developed bottom-up, and it went through several iterations based on the feedback from the scientists as well as the people working in the lab. Okay, let's look at the second component, which is technology. So we have a system called Specified Collection Management System. This system was developed based on Specify. It's an open source, primarily developed for biological collections. So we have adapted that collection for the geoscience sample requirements. And as you can see, currently we have more than 65,000 samples. Primarily our rock and soil sample have been properly curated in the system. So which means that the sample curator can use the system to manage the sample, whereas the scientists can use this system to locate their sample of interest. So this is an overview of the system. As you can see, there is a several function. You can search samples. You can also upload the sample in a spreadsheet in a bulk. You can also generate lab report. There's also function to loan the sample, to return the sample, and so on. So basically, it covers most of the function needed to manage physical samples. Just a more specific view, for example, you can use the query builder to search sample from a project, and then you have the result view in a tabular and also on the map view. From there, you can generate a report, which you can attach as an appendix for your projects, and you can also print label, which you can attach to the actual samples as well. Okay, let's talk about the people. This is a very important aspect. So as I say, in our project, we have identified what are the important roles and their responsibility to ensure end-to-end sample curation. We also have organized several talks, hands-on sessions, and we also have a help desk to actually support any help the scientists or the curator needed in applying the guideline as well as the tool. And most important part is this work has been endorsed by our leadership, which means that all the upcoming new project, all the samples that will be collected will follow those guidelines and will use the system. So this really helped with the wider adoption of the work we have done through this project. So just to conclude, effective sample management go beyond technology piece. It requires processes, technology, and people. All these three components must work together to ensure end-to-end delivery of sample curation and management. So our next focus, the next phase of the project, which is the phase 2 of the project, we are trying to bring new samples now, water and vegetations. We also integrating the system into other services. For example, we have a field collection mobile app so that when people use the tablet to collect the samples, and then when they return to the office, we can also sync that information back to the system. So that really can automate the data transfer and entry. That's all. How am I doing? Okay, good. Thank you.
Great, thank you, Anu. I'll invite our next speakers up. So we've got Kristen and Shannon joining us. Great. You just need this.
All right, thank you, everyone. Let's try. There we go. Thanks for the invitation. Our talk will be the re-examination of historical secondary data given federal funding cuts. I'm Kristen Mastel. I'll be joining Shannon Farrell here. We are just part of the project team. These are all of our other partners and colleagues at the University of Minnesota, including also Nikki Galloway, who's at Old Dominion University in Virginia. So we'd like to start off talking about U.S. federal funding and data. So of course, since January of 2025, there's been massive changes to the American landscape. Very quickly, the Trump administration started removing government information, including federal funded research data. The data removals range from complete website takedowns to the suppression of data collection and the removal of specific variables from data sets. And this ranges from science and research websites to healthcare and social welfare websites. And many of these data sets are longitudinal in nature, collected over extended periods to track changes and trends. It's worth considering that some of these data sets may have originally included data that was collected in analog form. And this raises important questions about the continuity and preservation and integration of older data within newer digital records. Recognizing and recovering these analog components could be key to unlocking the full historical value of long-term research projects. Massive cuts to government science funding are really threatening the foundation of research across the country. And if this trend continues, we risk losing not only current projects, but entire generations of future scientific progress. So here's a snapshot of a few headlines about some federal data science removals. It's not just removal, but it's also altering and changing data. So how do we as curators trust the data and know it wasn't changed? How can you put it somewhere and know that it's actually accurate and not manipulated? So here are a few data rescue efforts for us locally at the University of Minnesota and beyond. While we're seeing these massive movements of erasing and redacting information and the underfunding of crucial research, there are groups working hard to track the changes happening and preserve and make available all of this public information. There's dozens of data rescue efforts going on, including some that are really hyper-focused and local. For example, at the University of Minnesota, some of our colleagues are collecting national park signs. As of September 17th, all signage and references to negative stories of American history are supposed to be discarded from parks. And you're welcome to explore these links in national parks on the website. While these attacks to open science impacts American public and institution, the impact does not stop there. Public data sets from the United States, including decades of satellite data, are used by researchers across the world. And here you can see just two examples used by colleagues in China and Rwanda to analyze climate patterns. So again, looking at the global impact of the redaction and manipulation of data sets. So, of course, with the Trump administration undermining the integrity of research, we can't help but think about how this affects data curators' work going forward. This means less funding for original research of scientists and researchers, but this also might be an opportunity for us to really highlight the importance of historical data and also work on representing it and collecting and making it available. Again, we're going to kind of shift and give you a few examples from agricultural research and development. And with that is historical data. Most of the focus in the world of data librarianship is on data being generated now. However, this primary data, the new data, analog data, is a little bit different. This older data can be sometimes in digital, but also non-digital format, such as lab notebooks, field guides, and photographs and maps. So with that, we're going to explore a few examples here at the University of Minnesota. For example, we are approached by a potato researcher that had over 50 years of potato breeding data. We've conducted surveys and interviews of our faculty. And with that was a survey of 108 of our faculty. We found that 48% of respondents are still using analog data in their research, and 16% said they currently weren't using it, but 35%, and 16 said they weren't using it, but they were considering using it in the future. So this shows that the majority of our faculty are still engaging with data for current and future research. And lastly, we conducted 17 interviews showing that we have a wide variety of physical formats that our faculty are using, and few had written methods outside of what journal articles have produced. So there's a lot of opportunity for data curation and librarians to work on formatting this data. So I'm going to pass it over to Shannon to talk about a few more projects.
So I'm going to blow through this pretty fast, but I'm just going to talk about a couple of projects that we have done at the University of Minnesota. The first is with our Horticultural Research Center. They are a center that's offsite of our campus. They had literally over 100 years of historical data that was in paper format in what they called a vault. It was literally a room with a large fireproof door. It was about 10 feet high, stacked floor to ceiling. Much of it was in those binders that I'm showing here on this slide, and it was a mixture of breeding data, accession data, some experimental data, some maps. Some of it was proprietary because it was, they're applying for patents. So we worked with them to organize this data and to prioritize what we were going to digitize. We couldn't digitize all of it. We inventoried over 250 notebooks, and in the end, we organized them into a scheme and a map. The next one that we did was with this NCROC. It's called the North Central Research and Outreach Center. We also wanted to look through their data and digitize some print records. They are just, again, working with fruit breeding data, primarily testing cold hardiness. So it's the furthest center that's up north in Minnesota. The data set that we worked with was about 23 PDFs, over 1,700 pages. It was mostly blueberry studies, like I said, some field notes, observations, analyses, and more. This is just a subset of the data that they have. There's literally 20 file cabinets worth still up there that we haven't even opened. And just as a point of note, this is one of 10 centers that we have at our university. So what are the issues? There are institutional challenges to managing this kind of data. There's no structures in place to know what to do with this stuff. That's why it's gathering in individual departments and labs. The discipline centers and labs are siloed. There's a lack of shared infrastructure. And we also need some sort of scalable workflows. They need advice on how to organize and describe their data and how to digitize it. So particularly with the paper data, we found some issues. We discovered a lot of ephemera. Archivists will, of course, know about this, but sticky notes, receipts, and so on just mixed within the data. We had a lot of difficulty reading handwritten notes, determining provenance, document order, and dates on papers. It was a huge mess. I also wanted to note that we've been working with digital data sets. So I worked with a now defunct NSF-funded center on campus. They came to us when it was when it was 10 years old, and they weren't storing it very well. The OS was not working any longer, and now they want us to look at it. And like I said, this is one of the worst data sets I've ever seen. And I'll just wrap up, but the successful projects that we worked with, what we determined is that making data fair with this historical data is incredibly difficult. And there's really no incentive for researchers, to work with historical data because there's no federal mandates and there are no journal mandates in place. So do the best you can. And we just leave you with some questions if you do decide to take on a project of this scope. Think about, can you actually determine what the variables mean? What's the methodology? Can you even find dates? Do you know who created it? Would you be able to create a README? Is there anyone you can talk to? What needs to be explained? And to end, these data sets are valuable. They're large, untapped resources. And we need help making scalable workflows and collaboration between researchers, librarians, archivists, data curators, digitization specialists, and so on. And just something to leave you with, this is what we are hoping to get help with. So adopting and promoting metadata and citation standards, finding solutions for just scanning data, creating templates for better specimen data management, and helping researchers do this work. So that's it.
Thank you to Shannon and Kristen. Really interesting work, really valuable work. I believe now we've got our online presenter, so we'll try and skip to him. So I'm hoping that Nicolas, you can take it from here. Thank you for joining us. Sorry about the technical difficulties.
Okay. Hello, can you hear me?
Yes, we can hear you well.
Okay, thank you. So thank you for inviting me to present in this day. And sorry not to be there, but it was a long way from France, you know. So I'm going to present you today something about which is not directly connected to data stewardship, but it is something which is important now for the valorization of data and publication. So we are going to speak about the link between data and publication in social science and humanities, and more specifically in France. Because I'm from France, I'm Nicolas Larrousse, I'm Deputy Director of Humanum, which is a national infrastructure for social science and humanities. And I'm going to present you what we are doing with both in articulation with and cooperation with other infrastructure in France to facilitate the link between data and publication. So this is a slide for the country. So in social science and humanities, linking data and publication is relatively new. It's not very, very organized in a way, and it's something that we want to foster in a way, and we want us also to facilitate for people the link, the way they can link data and publication. But nowadays, how they are doing, what they want, why do you want to link data and publication? Maybe for two main reasons: to cite the data sets, which is quite obvious, for the purpose of scientific validation, verification, and sometimes to illustrate also the research context, to illustrate what you have done with the data, what type of data you are dealing with, or sometimes now it's getting more and more important to give credit for people and also for institutions, because institutions now are asking to have this kind of credit, because creating data, as we saw in the last two presentations, it's very expensive. Maybe another way to use data and publication, the link between data and publication, is just to show directly in the publication some data, like an illustration, of course, an image, for instance, tables, soundtrack, video, and 3D object now, and this kind of thing. So right now in France and maybe more in Europe, because we are connected to a lot of different institutions in Europe, how people are doing this famous link. Generally speaking, the way to do it, it's a simple text citation. At the best, you have a persistent identifier, but generally speaking, you have only the name of the data set, which is not really useful. Yeah, it's pretty useful, but it's not really usable for machines, for instance. And it's very difficult to track the link and to find it and to publish it, for instance. Another way of using link between data and publication, it's, for instance, I say just before, to integrate data directly in the publication, for instance, with the use of IIIF, which was in France is very now common in a way. And also, what maybe it's more interesting at the level of infrastructure is to use metadata. So we have done a sort of exploration of the repository, data repository, and we find that people, for instance, in the DC terms description, they use this metadata to describe the link, to mention a link, for instance, at the data level, data set level, but also at the publication level. So what are we doing now to facilitate and to also to make things more consistent in a way about the link between data and publication? So just first, I'm going to show which infrastructure are involved in the two projects in order to do that. So Humanum is a generic infrastructure for data in social science and humanities. We provide services, and also we provide a data repository, which name is Nicolas. Open Edition is a publication platform from books and journals. And CCSD is it's slightly different. It's an open archive for research papers, but and the name of the repository is AL. But AL is very generic. It's not only for SSH. So there is a part dedicated to SSH papers, which name is AL SHS. In French, SHS is SSH, of course. And we also involve a more specialized infrastructure, which name is Metop, specialized in publishing process, mainly by using TI schema and a lot of transformation to facilitate the publishing process. So how do we see the role of infrastructure in linking data and publication? I think that maybe the first thing, as I mentioned before, is to simplify the life of users, And to simplify the life of user, you have a data repository on one side, you have a publication platform on the other side. So we need to build bridges between all these platforms and to try to be, as we say, seamless as much as we can do. And also, in order to do that, we need to develop specific APIs and also adapt all the interfaces, doing some UX, for instance, and this kind of thing. And another main reason, because I didn't list all the reasons to link data and publication on what infrastructure should do to link data and publication, we have a sort of responsibility to ensure that the link is consistent in the time. That means that the data set linked to a publication still exists and this kind of thing. in order to do that, we need to have good communication between platforms, and we are going to see how we do that. Just a word about these two big projects in France, big in the sense of social science and humanities, Alliance and Commons. And so all the four infrastructure mentioned before are involved in these two big projects. That means that we have a lot of financing during 8 years, more or less. And in both projects, we have a work package dedicated to build the link between data and publication. And of course, we try to align what in these two projects, we can to align what kind of standard we are using, what kind of procedure we are using. So we need to, in order not to even reinvent the wheel differently in the different projects. We didn't start really from scratch because there was a European project some times ago, which then was a IOSC pillar, and we tried to build a sort of proof of concept for the link between the data repository Nicolas and the publication platform AL. So during this project, we saw that we need to find some standards. So we identified mainly two standards: Scholix schema for the dissemination of links. Scholix is supported by DataCite and Crossref, more or less. And we also, so this is a way to publish the data and publication link. And also, as I mentioned before, we needed to have a protocol to make the communication between the different platforms easy. So it was obvious to choose Core Notify. There is a use case for Core Notified about exchanging information about data and publication. Also, we realized that we needed to create a specific metadata, not use existing one. To be really, really precise and clear about where do you put the information. And also we decided to express the semantic of the link by using DataCite vocabulary, for instance. That means that there is about 16 different ways to express a link between data and publication, like something like cited, by, cite, document is a supplement to this kind of information, and we have DataCite provide vocabulary, so we choose to use it. And the main job maybe was to adapt information system on both platforms to be able to do this link, and also to do some cleaning in the information system, because there were a lot of places where the link was described. Nowadays, the link between Nicolas and AL SHS is now in production, and it's in production still June. And the two platform is exchange information using the Core Notify protocol. So you can see, I gave you an example. It's not very easy to see maybe on the screen, but you know, on the landing page of a publication, you have a link, for instance, publication in AL, you have a link to the related dataset in Nicolas. So this was a link at the very infrastructure level. That means that at the information system level, and we want to go maybe further in the Commons project. We want to try to integrate data directly in the publication. And we are going to use the work done between Nicolas and AL at the infrastructure level. And we are going to use a specific schema to integrate data from the repository Nicolas and to show them inside the publication. So this is a work in progress. And so I show you that in that slide that you can take part of, for instance, an image to include it inside.
Excuse me, Nicolas. Sorry, I loathe to interrupt you. Really interesting talk, but we're actually running over time. And just out of fairness to the other speakers, we'll just need to wrap up really quickly. Thank you.
I'll finish it rapidly. So this is a workflow. You do a link and then you publish it on DataCite or Crossref. and then there is an event created, and it's published in Scholix automatically by Crossref, and then an aggregator like Scholix Explorer can consume it and disseminate the information. Okay, so my last slide. We are creating in France a sort of ecosystem of people using Core Notify, people, institutions, and repositories and platforms. So that means that we can envision to communicate with other platforms like Software Heritage. And there are a lot of work to be done, managing different versions of publication and data set, for instance, more platform, more integration in the platform, and of course, training user. And sorry for the time.
Thank you, Nicolas, and sorry to hurry you at the end there. A round of applause for Nicolas, and I'll invite our next speaker up, Mark. Thank you, Mark.
Kia ora. This is a data stewardship session, and I think what's really important for part of the data stewardship process is to look at standards, information standards. I want to just be a little bit more specialised here and talk about data standards stewardship. And specifically, I want to talk about their sustainability and their discoverability in the geoscience information space. Here's a great example of how standards work. And this is from the various geological surveys around Europe. They are supplying information served from their own countries to a portal, and these are coloured and symbolised and brought together in a very nice way, and such that you can draw information from these data through vocabularies, common purpose vocabularies, and you can create and get a sense of where the mineral deposits are, of different types of commodities, and the underlying geology. A lot of this has been achieved through work of the Commission for the Management of Application of Geoscience Information, CGI, it's much easier to say. It sits underneath the International Union of Geological Sciences. And so this is kind of our structure. So CGI there, I'm representing CGI here today, and we sit underneath the IUGS, so this is giving us a sense of our governance structure, and then we operationalise all our standards through various working groups below. We've basically done two major themes within. We published geoscience data models, so these explaining relationships between various geological features, and also in the mineral space, another one related to mining and exploration data. And these are supported by a lot of geoscience vocabularies. We've identified through those two models something in the order of 130, and so far we've published 56 of these, and these are machine-readable SCOS vocabularies. And these are getting used and repurposed in many other vocabularies through other agencies. The vocabularies are fairly sophisticated in that they're hierarchical, they've got definitions and sources, and in some cases multilingual translations. So the vocabularies were assessed in a fair context through a paper by Simon Cox and others back in 2021, and I've basically scored where CGI are sitting in terms of their vocabularies. And generally, we're doing pretty well, and we're meeting the various criteria that set out FAIR principles for good vocabularies. However, there are a couple of places that we're not doing quite so well or could do better, and that speaks to some issues that CGI have. These standards have basically been developed in a series of pulses of activity, or sprints if you like. And so this is where there are projects, and these are often multinational projects coming together and collaborating on the development of these standards. But these projects typically will only last for a few years, and then they basically end, the funding disappears, and so on. And so CGI has persisted through a couple of decades now, more than 2 decades, and we've overseen a lot of these pulses of development of standards which relate to ones that we ultimately look after. And this is quite problematic for us. What do we do in the periods when there are no funding resources, there's no people involved? How do we sustain those standards? So one of the ways we can do that is that, well, these are the kind of a list of things that we can help. But we've got to recognise we've got to keep up with technology shifts. So even though we've got a reasonably mature environment of these standards, we have to adapt to new technologies that basically help us make those even better. And we can do that by addressing and looking at all those complementary vocabularies out there. We're sharing resources with geological surveys, and Queensland is a particularly good example of a geological survey that is using the vocabulary space really well. We have to accept that these pulses of activity exist, and there's nothing we can do about it as a standards-related organisation. But we do have the advantage we got that good governance structure through CGI. And we can also extend that. So through CGI, we can look at our other international union counterparts who have geoscience data themselves and have standards, but maybe not the maturity levels to look after those. And they could even go beyond the international union, the geological space, into other groups and agencies. And then potentially we've got the ability to form coalitions with other science standards groups. And so this is one of the reasons I'm at this meeting, is to have those conversations with the wider science community around standard sharing and support. And in terms of the discoverability, as I said, we need to think about just improving a few of those FAIR principles that we're currently a little bit light on. We need to do a lot more promotion of our standards. So this is something that if we want to keep our standards discoverable, then we actually have to do a little bit of promotion of them. One of the ways we can also assist that is through developing a catalogue of geoscience information. So we're looking at ways that we can become more of a focal point and a place for people to come and find geoscience standards. And once we've got that catalogue, we could potentially have that linked to a register of wider science standards. And this is another thing I'd like to see CODATA take on in terms of taking some leadership in terms of developing that register of science standards, information standards. And I'm going to conclude there. I've got a couple of involvements in some sessions, one of which is this afternoon and another one on Thursday. So if you want to know a little bit more, that'll be part of that discussion.
Thanks very much, Mark. I'll invite our next speaker up, David. I do hope we have time for questions. We're going to be a bit pressed, but there's lots of interesting things coming to mind for me, and I'm sure for the audience too.
Sorry. Hi, I'm David Currie, and I'm going to talk about how we've used frameworks for managing our data within the Marine Institute and try and highlight the sort of data stewardship concerns or practicalities around that. So the Marine Institute is Ireland's research body, which deals with collecting marine data. We also carry out marine research. We've got around 200 to 300 people, depending on how you count. And we're based, our headquarters is on the west coast of Ireland, just outside Galway. And we have a number of satellite locations around Ireland as well. One thing in the past that's been quite useful is to look at the real map of Ireland. And this includes Ireland's marine domain. which is 10 times the land domain. So this sort of, it's been a useful communication tool to actually show why marine research should matter in Ireland. I won't go into our corporate strategy because I'd like to keep you all awake, but in terms of our digital strategy, one of our aims is to lead the digital ocean transformation and be fully involved in that within Ireland. In terms of our activities, we collect and publish data on fisheries and ecosystems, aquaculture, food safety and marine environment, oceanography, climate change, shipping and transport, and seabed mapping. And we also manage a number of research infrastructures, particularly we have 2 research vessels. So our latest one is the Tom Crean, which is 3 years old now. And we also have things like data buoys, which are sensor networks collecting data. So I wanted to highlight the challenges of marine data management, and I don't think most of these are necessarily unique to marine data management. I think people involved in sort of Earth observations and geographic data management would be quite familiar with a lot of these issues. So we're collecting data at a particular place at a particular time. If we mess things up, we can't go back and get that data again. It's gone. Particularly with historic data, there was a mention earlier about going back and trying to recapture that data, which is particularly valuable for us because we can't just run the experiment again. If we collect data in 1956 and we don't store it properly, that's gone forever. Generally, we're looking at data that has long time series. So we're collecting the same data for multiple years, and often that data won't be used until it's got a significant time series. So it might be 5 years before you actually start being able to use the data. It can be expensive. So particularly around like research vessels, if you're going to run a research vessel and carry out an experiment, there's a high cost to that. Culture, certainly not everyone, but there's people within our environment that didn't necessarily get on board with everything we're trying to do. They're busy, they're interested in their own research, they don't want to necessarily hear about data management. And that's certainly not everyone. There's plenty of people who were interested, but it's not uniform. Interoperability has been an issue in the past, particularly where we have different data collection groups that haven't spoken to each other. The data really hasn't been interoperable. It's all used different standards, different formats, different code lists, and it's still an issue now. Technical limitations, as I mentioned, we do have quite a lot of research infrastructure in place, but you need people to be able to process that. You need to be pulling that together. It can be a challenge to have the technical ability to pull everything together and maximize what you're trying to do. I tend to work in fisheries data, and we have a lot of confidentiality issues and issues with personal data, and trying to make that as open as possible but as closed as necessary is a constant discussion point. And as I mentioned, we've got diverse communities. So there are groups that have been far ahead for a number of years, particularly the oceanographers have been leading the way, I think, in terms of fair data. And we've been trying to play catch up with some of our other groups there. So around about 2017, we had a data strategy, and we came up with the objective that we wanted to be a trusted source of high-quality data with well-defined, reproducible processes. So I'm going to talk about the 4 steps that we've gone through so far on our journey, hopefully to get closer to that objective. And the first step is from 2017 onwards, is our data management quality management framework. And I'm looking at the sort of accreditation and implementation here. So we worked with the International Oceanographic Data Exchange, which is under the umbrella of the IOC as part of the UN, and they publish guidelines on how to implement a sort of quality management system for oceanographic data. So we thought that was a fantastic starting point, and we started to follow that, and their systems aligned with ISO 9001:2015 standards. So after going through a process, we ended up with sort of 3 steps as our output here. The first step is a model. I won't go into the details. The second step is a quality manual, and we spent quite a lot of time going through the process to write the manual. But the real meat of the system is in the implementation packs. So essentially, for each of our data processes, we create an implementation pack, and an implementation pack has a data steward. And an implementation pack would include things like the data management plan, the requirement specifications, process flows, and SOPs. So the next step was 2020. So we thought, actually, we've got this data management, quality management framework. It's aligned with ISO 9001. Why don't we see, is it possible for us to actually get certified to ISO 9001? So we did a gap analysis, looked through the standards, looked at all the definitions about, are you sure? about things you should do, and then we came to the conclusion that we were good on the compliance, in the sense our manual was up to date, but we weren't very good at showing the evidence for effectiveness and continuous improvement. Step 3, initially we'd concentrated on our operational data, so that's data we were collecting on an annual basis ourselves, but we also work with research projects. So it was to expand the QMF to actually incorporate the research as well. And then step 4, we act as the National Oceanographic Data Centre. So within that remit, whilst we collect data ourselves and publish it, we also want to be able to take in data from other people. So we came up with the digital preservation framework based on OASIS, and then also got certified to Core Trust Seal. I'll go through the results quickly. So we have 135 data sets and data processes under the QMF. Generally, we've seen improvements in terms of making things better, improving our processes. Our customers are happier because we're able to give them more confidence about our processes. We've identified areas of risk, particularly where there's like a single point of failure, where there's one person who's doing the whole system. So we've at least been able to identify those areas. We've been able to provide a lot of documentation, and its training material for new starters has been particularly useful. And there's a number of EU pieces of legislation that are coming through that are sort of a secondary reuse of the data. So actually having the clear provenance and documentation around how the data is collected has been the most useful thing. I've got like one slide. Discussion, things we could do better. We've been trying to improve the actual continuous improvement aspect. So not just documenting what we do, trying to get better at it. We've been able to make our data more fair. So things like adding a data catalog entry. We're better able to cope with new legislation. And I was going to talk about audits and how much work there is there. I will skip past that. What I'd say for the data steward, it's a lot of work. It's needed commitment from top-level management. And we're working with the Irish Data Stewards Network to be used as a case study and hopefully share that information more widely. So the conclusion was the frameworks are great, but you need the people in place, and you need the commitment to make sure those people have got enough time to work with you and actually do their job as a data steward and buy into that. So there's a link there to a paper that was published earlier this year, which has more details. And thank you very much.
Thank you, David. I'll invite Jeff up as our next speaker.
Hello, my name is Jeff Shim. I teach scholarly communication practices at Sungkyunkwan University in Seoul, Korea. I'm going to talk about a recent project, which was a fair evaluation of a data repository named Korea Biodata Station, or KBDS. The Korea Bioinformation Center, which is part of the Korea Research Institute of Bioscience and Biotechnology, produced KBDS. Korea is gearing up its policy and platform initiatives in order to take advantage of research data availability. One of the results of these efforts is the Korea Biostation that I'm going to talk about. There is a statute from 2009 that sets the rules for collecting and using biological data for research. The Korea Bioinformation Center is mandated by law to collect data and manage platforms for data sharing. KBDS is a national biological data repository that gets research data from government-funded research projects, organizes it, and makes it available through its own platform. And it claims that it follows the FAIR principles. This made me really interested. And I asked Dr. Hae-young Jung, who is in charge of KOBIC, how it meets the FAIR standards. And he said, absolutely, KBDS literally makes data findable, accessible, interoperable, and reusable in the literal sense. And I said, okay, but it's got to be more than that, right? So I suggested a formal review of KBDS, and he agreed without knowing what the result is going to be. So KOBIC, in addition to KBDS, is also responsible for other biological data platforms and services in Korea. KBDS is a comprehensive data platform that encompasses the entire data life cycle with a special focus on data curation and quality control. KOBIC works closely with the Korea Institute of Science and Technology Information, our national supercomputing center and data infrastructure provider. I already mentioned that KBDS performs extensive data quality control checks, and this slide shows how they do this. KBDS has a total of 9 different databases on data types. Out of these 9 databases, KRA holds the most data, is the largest one. As you can see from the graph on the right, approximately 80% of the data is publicly accessible. I won't go over the FAIR principles and evaluation metrics, but I will say 2 things. First, FAIR evaluation gives a clear path to FAIR compliance. That's for sure. And second, there aren't many FAIR assessment findings, results out there that we could find. I think I can skip this for the sake of time. As part of the evaluation, people undertake what they call a FAIR implementation profile. We already heard about it in one of the presentations. We didn't do a full FIP, FAIR implementation profile, but we did a smaller version, they call it mini, instead. In the future, we want to do a full-scale FAIR implementation profile. There are a number of choices you have when it comes to choosing a specific FAIR evaluation tool. We picked the FAIR Plus dataset maturity model since it's primarily focuses on biological data. There are 6 maturity stages in the FAIR Plus DSM, with 5 being the highest. It has 3 dimensions of evaluation criteria for each level: content-related, representation and format, and hosting environment capabilities. The highest score you can get from this model is 5.0. A score of 2.0 signifies that the repository being looked at has met all of the requirements for level 0, 1, and 2. If you miss even one indicator at level 2, your score will be below 2, even if you have indicators checked off at upper levels, including 3, 4, 5. We concentrated on the KRA database for this evaluation, as it accounts for more than half of KBDS data. We examined the complete data set at the sample level. KRA has 3 tiers. One, KRA has project type at the top level, sample type in the middle, and data type at the bottom. Our team at Sungkyunkwan University, which is an outside group, conducted the evaluation. Of course, we had to work closely with the COBIC staff to learn more about the database and how it works. And we largely used metadata polling to complete the review. But when we needed to, we got supporting documentation from COBIC. This slide shows how the evaluation was conducted. The external evaluation team, that's me, and my students got much of the data by scraping from public metadata from KBDS. Scores were determined for each data set, and then the overall summary score was computed by combining all of the individual scores. This slide shows a resulting page out of 22,000 for a particular data set. For each indicator, if checked, it means the indicator met the criteria being evaluated. The total fair compliance score for KBDS was 2.94. That means KBDS meets all of the requirements at levels 0, 1, and 2. At level 3, there was only one indicator that it did not meet across. We got some partial results for levels 4 and 5. And in general, I believe this is a really positive result. Also, we are very impressed by how consistent the results were across all the data sets. We think that a number of things have contributed to the results. One, KBDS is a fairly new platform. It doesn't carry or keep any old legacy data. Second, the curation and quality control procedure makes sure that the metadata and data contents are valid. We think that the KBDS has reached the community level of standardized data based on these results. In order to attain the cross-community level of supplying semantically typed data, that is level 4, there are a number of things that need to be done. One important lesson we learned from this evaluation is that much of the work, this fair evaluation, can be automated in our context. The next step we need to do is evaluate all of the KBDS databases, not just one, but probably 7 or 8, and at all levels, including levels 4 and 5. This was the first time that a fair evaluation compliance review was conducted on a big data repository in Korea. We think that this kind of examination is helpful on many levels. One, it gives KBDS a clear way to make things better in the next iteration. And also, now they may say, with a little bit of confidence, that it follows fair principles at community level. That's it, all I have. Okay, thank you for your attention, and I'd love to hear from you.
Thank you, Jeff. Our next speakers, Mickey and Laura, have done a recording.
And thank you for being here. I'd like to present today on some research we're undertaking in the EOSC Eden project, where we aim to develop deeper understanding of identification, selection, and appraisal in contemporary digital preservation practice. But before I go any further, first I'd like to begin by acknowledging the owners of the land that we're meeting on today at SciDataCon and pay my respects to elders past and present. So I would like to quickly introduce myself and the team who have produced this work. My name is Laura Malloy and I'm the research lead at CODATA. CODATA is the Committee on Data of the International Science Council, and we work on open data and fair data as global public goods. I have the great pleasure of working with the TIB in Germany on this work. My co-author and our work package lead, Mickey Lindler, and the other task leads are all TIB staff. And you can see more about TIB on this slide here. And we're working together on the EOSC Eden project. Eden sort of stands for Enhancing Digital Preservation Strategies at European and National Level. And basically, we seek to understand the current digital preservation landscape, identify common standards and practices, and provide new solutions and approaches that will help institutions to select and preserve high-quality, fair research outputs. So this is a relatively small project in some ways, but it is an ambitious one, and it's clear that if we're going to work successfully towards these aims, well, a useful starting point is to understand in as rich way as possible the current practices in the professional digital preservation sector across organisation types, and to understand the frameworks and guidelines that are currently being drawn upon to influence practice. So an early activity is what I'll be telling you about today, which is a relatively large-scale survey that we're currently analysing. I'm going to sketch the aims and design of the survey, and I've chosen a couple of initial findings to tell you about. But the main purpose of this short talk is to flag that the activity is underway and where you can find out more about the project in general and about the survey work in particular. So firstly, here we have some key facts about the survey to give you an overview. Firstly, the survey ran from the 2nd of May to the 30th of June on the EU survey tool, so that was this year. And it was aimed at digital preservation practitioners across sectors and disciplines, including research, cultural heritage, and industry. We got 258 responses altogether, 250 of those were valid. And we had 4 main sections of questions. So the first one was about organisation and role, including the type of organisation, where it's based or headquartered, and its size, the respondent's own role within the organisation, and the specific research disciplines, if any, for which the organisation preserves digital data objects. And we're not using organisation as a term to embrace the research sector, cultural heritage organisations, and industry, so we're trying to be as open as possible, whilst making sure that the focus is on digital preservation practice within those organisations. Second section was about frameworks and guidelines. So we provided a list of well-known frameworks and standards in the area, gathered from research and consultation across the project and the project network. We presented those, and respondents were asked to choose for each of these whether they'd heard of and use, heard of but don't currently use, or have not heard of. And we also asked about a definition, an agreed or working definition of long-term in the context of preservation. In section 3, we investigated current practices in identification, appraisal, and selection of data, and that was about how digital data objects usually enter the organisation, if and how they're assessed, and the initial preservation period, and what happens after that. And then the 4th section was about discipline-specific requirements for long-term preservation, and that addressed lots of different aspects of that question. And then section 5 was voluntary contact details, because we might use some further interviewing next year to expand on the themes we've identified. So who responded? For organisation type, you can see the pretty rough data here. Please note the respondents could choose more than one option to this question, so the numbers here total more than 250. The main point I want you to know is that the most frequently recorded organisation type is university library at 60 responses, and organisation types are listed here on the right-hand side from most to least frequent. We are working on a more coherent way to present this section in the report just now. We were happy with the variety of organisation types here, and personally I was particularly pleased to see so many museum or gallery responses at 17. Something I was a bit less satisfied with, though, was the lack of responses that we managed to get from Africa and the Middle East when we're asking about location. I'd like to note that we put specific effort into connecting with organisations and projects who have real and valuable collaborative networks all over the world, as well as creating translations of the promotional materials. But unfortunately, we were not successful in getting responses from these areas. So we don't have the benefit of expertise from these global regions, and I'd welcome any constructive feedback on how to improve on this front. Having said all that, though, we had reasonably good pickup from North America, Europe, and Australia and New Zealand. Some pickup from Latin America and Asia, and I'm grateful for all those responses. And again, here you can see the country names listed from most to least frequent on the right-hand side of the slide. When looking at organisation size, we used the Eurostat categorisation of enterprise size, and again, we had a good response rate for this question too. Most of our respondents reported coming from a large organisation size, and the response rate decreased along with organisation size after that. And here respondents did need to only choose one response, so this data is a little bit more orderly. And finally, for respondents on their role in the organisation, we're using the Library of Congress, Digital Preservation, Outreach and Education Conceptual Pyramid for staff levels here. And again, we were quite pleased to assist the levels of response as we had targeted the survey at those identifying as practitioners, and that is the majority of responses that we got here. But again, you can see that the respondent can choose more than one role, and a certain number of respondents, I think about 20-ish, reported performing more than one role in the organisation, which is interesting in itself. Now, moving quickly on to initial findings, I'd like to note that we're right in the middle of the analysis phase. We're in this spreadsheet-filled era, which I am enjoying, but is kind of hard to report upon. But here I've cherry-picked 3 interim findings that may be relevant to your interests. The first one is here, and it's about awareness and use of frameworks and guidelines. So I mentioned this earlier. We displayed a list of frameworks, guidelines, and standards that we identified through desk research and consultation. And we asked each respondent to indicate whether they use each one, have heard of it but don't use it, or have not heard of it. Here are the ones that are most currently reported as being in use, and we successfully validated this by asking the opposite as well, by which I mean ranking these as marked as unfamiliar by respondents, and that mirrored these findings here, so we were pleased with that validation. So if you're interested in or even involved in the production of any of these guidelines and frameworks or standards, you may be interested to see how these are performing in terms of awareness in this sector, and we'll put more about this in the report, of course. Second of selected current findings is about the definition of the concept of long-term in the preservation context. The most common working definition of long-term that was reported was, quote, forever or as long as possible, or another expression of an unlimited period of time. And you can see that has the most votes in the table on the left. You can also see the other scores. The second most common was a minimum period of 10 years, and other responses had much lower popularity. But a further response worth noting was that 9 respondents specifically brought up the importance of object accessibility and usability, usually in conjunction with a stated minimum time frame. These responses emphasised the point that an agreed minimum time frame should be specifically an indication of the time frame for which objects are available and accessible by users, in addition to being preserved. And this idea was very poetically expressed by this response you can see on the right. An archive without its users is merely a desolate repository for information that is never accessed. And I sort of feel like if you ask French archivists this sort of question, you can expect this sort of answer. It is really wonderful. My third selected finding was about threats to FAIR over time. We asked the question, which factors could reduce the findability, accessibility, interoperability, or reusability over time of digital data objects preserved by your organisation? This naturally brought in a wide response rate, a wide range of responses of, frankly, varying relevance and cohesion. But in fact, we got 170 responses, and I quoted these to 52 nodes here. I tried to create a top 10 for you on the left-hand side, but there were so many with the same score that we've actually crammed in 11 of the most frequently reported threats to FAIR data over time. We can see here that poor metadata and a lack of sufficient finance cover the top 3 problems, and of course this will be no surprise at all to anybody who works in digital preservation. So that's the end of my super fast time today. I hope that I have given you a couple of things to whet your appetite for more on this work, which is my aim today. We're going to be promoting the formal reporting on this work, which will be coming out later this year through the website and the Blue Sky account, both of which are on the slide. And I'd be really happy to receive any feedback, requests or questions to the email listed here. And all that remains is for me to say thank you so much for listening.
So Laura and colleagues won't be joining us for questions afterwards, so do jot that email down if you'd like to ask a question. I'll invite our final speaker up, Alvaro.
Oops, me too. Okay, so I'm going to go a little faster so we can have time for questions. I'm going to be presenting the implementation of bridging metadata standards in our institution that is called Data Observatory in Chile. We are an organization that is focused on public data to make it more accessible to the common people. We are a non-profit. And this is a work made by Alejandro and myself, Alvaro. So let's go. First of all, I want to acknowledge and celebrate the first Australian on whose traditional lands we meet, and all the ancestors present and past. So, what's the motivation or the problem that we are trying to explore with this is that we have a lot of information right now, not only from research, we have a lot of information for a lot of devices, your cell phones, Starlink, several satellites, and then a lot of information every day, and this is going to be growing exponentially. So we have a lot of data that we need to catalog, and we need to catalog correctly. And we have in Chile, but in other parts of the world also, a lot of metadata standards going on. So we have DataSci, Dublin Core, OpenAIRE, ANID, that is the National Agency for Discovery and Research. That will be more or less the translation. And they have their own MINIT standard that is a mixture of DataSci, of Dublin Core, and OpenAIRE. So we have to do something about that to make it work. And we need some way to make it kind of translator between this schema in order to allow ANID to harvest all the information in a proper way. So we have a lot of, did I pass there? Ah, yes. A lot of standards going on, and key difference is that they sometimes match, sometimes do not match in the element names, in the filters. Some have control values, some do not have control values. So we have some examples of problems with the resource type that is not the same in each one of these metadata standards. We have embargo dates that is not defined in the same way. So we have somehow see how we can translate them and make it talk. One of the key interoperability challenges is the compatibility when you have more than one field that can fit in some value. So most of the time, if it's one-to-one, no problem, but most of the time you have many-to-one and one-to-many, and that's something that is very hard to deal with. And the semantic ability also, but also the value standardization, that is a topic that has been very common in all the talks, in several talks, when sometimes you use the country code, the CL in the case of Chile, or maybe you use the name of the country, or use a coordinate, whatever. That sometimes make a lot of trouble. But also, one of the key things here is that you could lose information when doing this translation. So some schemas do not support too much details, when others do have a lot of details to some fields. So we are getting ready to implement CDIF on top of this translator. It's not yet implemented, but we are going to that. That's where we are aiming to go. So we are, in the translation, we are not creating a new schema, but we are trying to simplify it and make it more atomic in the sense that we are creating like a dual metadata that is not a real metadata, but it's a simplification in order to be more able to communicate between these schemas. And on top of that, we also are trying to, of course, make it ready to CDIF, as I said before. And you can see that, well, this schema is more or less, sometimes we have some things in common, but most of the time we don't have some things in common, and there is where the translator has to make the work. How we are doing this? We are creating a big spreadsheet with a lot of columns and rows. We are trying to make all the equivalence between the schemas. The idea is going from this to an operational level. So we have a script that grabs all the information here and translate between one schema to another when possible. Of course, sometimes you cannot go from one to another, but when it's possible, you will try to do it using this spreadsheet as a base. So if you have new properties or new schemas, we just add a new record to this spreadsheet that we have there. And how more or less is working, and can you see the pointer? It's not too good, but in the right side, we have an example how we do the translation within the CDIF. That is not the best example, but it's the most clear one, between CDIF and the DO metadata. And we have that column that is there, when we have how we move, in this case, the data from one schema to another when a sub-property is defined. So we split that record. Sometimes we have to merge those records. Sometimes it's only 2, sometimes it's 3. So it's a very funny exercise sometimes. What are we doing? We're implementing this as an API in the future, not yet ready, but going on in that direction. On top of that, we will build OpenSearch to query this and in a much faster way. We are we are saving all this information and in AWS and S3 and Parquet file, and on top of that, using DuckDB to make the queries and store the information. By the way, if you have tabular data, please try also always to use Parquet files. Then we go to a validation process with ANIT, that is the funding institution for all the research in Chile. So this is an example of how it looks at the end. I will not go into much detail, but we are very similar to DataSite. We are based on the DataSite schema. We are trying to make it more atomic when it's necessary, but you can see that we have different ways of calling, for example, the issue date. Sometimes it's a property by itself, sometimes a sub-property of a date property, and the same with the copyright and embargo and all the other sub-properties that you can imagine. To end, the limitations is, of course, that we don't have always a relation one-to-one, one-to-many that we can establish, but we are trying to prioritize the most common and the most important fields. There is a lot of curation and ontology effort in this. We want to expand all of this using OpenSearch, as I said before. On top of that, and a good website that common user could make the queries, and of course, call to action. I invite anyone that wants to cooperate with this big spreadsheet that we are making to make contact with any of us in that observatory. That's all. Thank you.
Thank you, Alvaro, and all our speakers. I'll invite all the speakers back up to the front, and we've just got a few minutes for questions. So if you have some ready, please put your hand up. Questions for any of our presenters today? So I can't see that we've got any questions online. Are there any questions in the room? Okay, I'll start with a question. So, Jeff, you mentioned that you felt it was a really valuable exercise evaluating the repository that you did. Is it something that's now going to be done for the other repositories you mentioned?
Yes, that's a really good question. So there is a certain level of recognition of FAIR principles in Korea, but none has been done to actually measure the compliance level. So I guess this is a really good starting point, and we want to spread to other national repositories in order to elevate the level of FAIR awareness in Korea.
Yeah, great. Got a question over here. Claudia, please introduce yourself as well.
Hi, my name is Claudia Medeiros. I'm from Brazil, University of Campinas, and I'm afraid I just missed the first part of the sessions, but I have a question for Alvaro. Alvaro or Alejandro? Alvaro, I'm sorry. You have kind of a search interface to several repositories, is that it? That translates different kinds of metadata standards. I didn't quite understand. You said you do translation across metadata standards to CBIF, right? CDI. More or less. Okay. What kind of data sources or repositories are you looking at?
Yeah, we are primarily looking to the repositories that a need is funding. All the research that a need is funding, then that's what we are doing. We are still developing this, so this has no interface yet. It's just programmatically, but the next step is to build something on top so the common user can query and do all the search.
Thank you. Sorry, thank you. I'm Anthony Cooper from South Africa. And as a South African, I would have thought the American federal data would have been well backed up and everything like that. So the question, has your new government prompted the community to realize that maybe they've been a bit slack with curating all their data?
Yeah. So I don't think that we know clearly what is going on behind the scenes. How do I say this? I trust our scientists and those that are collecting the data, but I don't trust that the government and some administration is not going in and changing things. And so one real big primary example that we didn't have time to talk about is that there's a lot of public health data sets where they were using the term gender, and someone literally went in and did a control find replace and changed it to sex. And in that case, I presume that it is backed up somewhere, but it's not publicly available, except for all of those data rescue efforts that are going on where they grabbed it before the government got to it. This same thing happened in 2016. There was a lot of data rescue going on then as well. But yeah, I don't know where it is, and I would imagine that those who do know where it is aren't talking about it. I wouldn't, so.
Thanks. We've got time for one final question, just quickly.
Just another question. Maggie Smith from Geoscience Australia, just another question for Shannon. The paper documentation that you're trying to save, is there going to be a situation where you're going to have to say that this data is beyond approach? And I just wondered how you prioritise.
Oh, definitely. The potato data that Kristen mentioned at the very beginning was sort of one of those, because there is literally no one studying potatoes anymore, and we didn't know how to approach it, because, you know, trends and disciplines evolve and change, so that was hard. We do still have the paper documentation, but we don't know what we're going to do with it further. In terms of the blueberries, I will freely admit that I got a high pinch of anxiety and being overwhelmed when I walked into their room and saw 20 file cabinets full of research data. You know, those things had been turned into papers and reports, but not the raw data. And so we are unclear about what we're going to do with that. I think, as I was mentioning at the end of the talk, and I know I zoomed through it, is that collaboration is really going to be important, and we're going to have to find people within those research centers who can work with us to do the best we can. And it probably will end up just being scanned. That's what I'm seeing. And we will prioritize based on what they think is the current research that would be most reused. So it's not always the best thing. This is something I struggle with. So my background's in conservation and ecology. I can't predict what someone is going to need 100 years from now or 10 years from now. So it's sort of working with them about what we value now, and sort of going from there. And if there's resources in place and we can go backwards, then that's what we'll do. Yeah.
Thank you, everyone, for your valuable questions, your attendance, and to the presenters for sharing your vision of what data stewardship is, what's important to be thinking about right now, and encourage you all to continue these conversations. I've got lots of questions still, and there's a lot of work to be done here. So thank you very much, everyone.